Okay, intermediate value theorem. This is a biggie. This is a really, really important theorem, and this is baby step number 1 of this theorem. There's all kinds of intermediate value theorem corollaries. A lot of them you're going to talk about next year.
Yeah, but we're going to talk about this part of the intermediate value theorem, this part right here. So it says if A and B are real numbers with A is less than B, so that means A is a smaller number than B.
Right.
And if F is continuous on the interval from A to B.
In other words, when you put your pencil down and you start to draw this graph, you never pick your pencil up from A to B.
Right. Then F takes on every value between F of A and F of B. Okay, F of A is the Y value at A. F of B is the Y value of B. So, in other words, if Y naught is between F of A and F of B, then Y naught equals F of C for some number C in A to B. So that's the part where I think it gets confusing.
It's really fancy stuff in there, but basically what we're saying is if you take one X value to start and one X value to stop, that you will get a unique Y value for every X value in between.
Right, because it's continuous.
Because it's a continuous
function. And so what that is really important, what's really important about that is this next part. If F of A and F of B have opposite signs, so if like in this graph,
one Y coordinate is negative
and the next one is positive, then at some point between A and B, you have to have a 0.
You have to. It has to cross the x-axis and give us a 0 root or solution. It has to do that.
So here's what that lets us do, kind of. Let's give. I'm going to try this and see if you follow what I'm saying. Like, okay, if we know it's a continuous function, and they tell us we've got like 2, -5, and 7.
3.
I was actually going to go with 3, and then I switched to 6. How
okay.
weird is that?
Yeah,
okay?
It's really weird.
Okay, so let's say that they tell us we've got some random function. It's continuous between 2 and 7, and these 2 points go through it. We know because this is a negative and because this is a positive, we know somewhere between there is a 0.
It crosses the x-axis.
It crosses the x-axis.
So, do we know exactly where?
We don't know exactly where.
We don't know.
But let's think about, let's just graph it really quick. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So 2, -5 is down here. 7, 6 is up here. So doesn't that make sense that if this is a continuous curve between these points, it doesn't matter what it looks like. It could be all sorts of squiggly.
It could bounce 5 times in
Yeah,
there.
and it could even go through more than once, right?
Sure.
But we're guaranteed it has to have at least one 0.
One.
And it could be like a straight line. Oh, look. Well, that's not really a straight line, but a kind of straight line. You know, that went through once. Or it could go up and down.
Who knows?
But we know it goes through at least once.
Intermediate value theorem.
The intermediate value theorem, also known as IVT.
Yeah.
Is it known as that?
It is now.
It is now, IVT.
Yeah, the IVT.